thermal mapping and settling. So what happens when, let's say, that filler isn't behaving as intended? So some common challenges that can occur with the dispersion of that filler, things like agglomeration or sedimentation to one side. When we're looking in something like a TIM where we want very uniform and even heat transfer, from a material perspective, this can, of course, negate that, result in uneven heat dissipation. Excuse me. This will, of course, potentially impact your performance and safety risks that can come with that. But there's also a testing perspective aspect here to consider. Different methods, all methods, will have a certain, let's say, underlying assumption in what we're actually measuring. The volume or the area that's being measured. Is it directionally dependent in plane versus through plane, or is it taking an average? When you have non-idealities of fillers within the sample, this can compound and result in some increased biases depending on what method we're looking at. So it's really nice to have a way to identify this. So with the MTPS, there's what we call thermal mapping. So in this example that I'm showing here, this was an epoxy resin with a conductive metal nanoparticle dispersed throughout. As we can tell just by looking at it, not a great sample. There's clearly areas where there's higher and lower concentrations, non-uniform, not the best. But to help really quantify this, and in the example of maybe your sample is opaque in nature and we can't just visibly detect this, the MTPS being a single-sided sensor, we can put that surface in contact with a specific location, do that at a few different points across your material, and then very easily get some quick feedback on that thermal conductivity at that location. The MTPS has what's known as a gartering, which provides a controlled directionality and localized spot measurement within a material. So if your sample is potentially something along these lines where we're seeing differences at each location, again, the MTPS is a really nice quick tool that we can use to help quantify some of these challenges. And of course, let's say you had a nice uniform material, well then whether you measured at the center, the top, or the bottom, your values would all be essentially the same. So as a quick R&D check, this can be really useful, especially early on, to help with that iteration velocity. So you can really kind of develop these samples with confidence and bring them through that, production, or get them to production earlier.